Hi viewers, welcome to Deep Learning Module 5. Let's start this module with understanding the loss function. So what is loss in the neural network? Loss is the difference between the predicted output and the output that is obtained. It's very natural that unless and until the network is being trained perfectly, the loss component or the loss computation will be big or great or greater. Obviously the objective is to reduce the loss computation and reduce the loss to the minimum. That's where the perfect neural network lies. So once the output is obtained, the loss can be computed for the specific output, but by looking at what the model predicted versus the true label. The loss computation depends on the chosen loss function. So probably you may remember, we have something called as activation functions. There are multiple activation functions which determine the firing of the neurons, isn't it? If we would remember right. Similar to that, we have many loss functions which is used in the loss computation. Briefing the gradient, concept of gradient again. Gradient of a straight line shows how steep a line is. So the change in the direction of y and divided by the change in direction of x gives the gradient mathematically. As we are going to discuss and use this term gradient at various places in this module, a small recap of the component gradient was shared. Thanks for giving this opportunity for me to introduce you an interesting concept called as regression. Regression is a relationship between any two things. So here on the screens you can see the screenshot of a mountain, and this picture is not just a placeholder. We are going to learn the concept of regression using this mountain. Folks, you may know the temperature rises, the temperature decreases with height. When you go up, the temperature naturally decreases. This is a physical phenomenon. Imagine you stay on the ground with certain temperature and you go up, the temperature starts decreasing, is it? So it means that depending on the height, your parameter called temperature changes. Not only that, your temperature not only decreases just because of the height, there are various other parameters, something like humidity, height above the sea level. That's what we discussed earlier. So imagine you stay on the ground and the temperature is 70 degrees Fahrenheit. You start climbing a hill, and as you climb, you realize that you are feeling colder and the temperature is dropping. Yes. When you reach the hilltop, which is 500 meters above the ground level, and you measure the temperatures 60 degrees Fahrenheit, a decrease of 10 degrees Fahrenheit. We can conclude that the height above the sea level influences the temperature. Yes. Hence, there is a relationship between height and temperature. So this term is called as regression in statistics. Coming back to the previous slide, it is a relationship between any two things. So here we are explaining the example with the help of this mountain and temperature. So here let's classify the variables as dependent and independent variables. The temperature depends on height and hence is the dependent variable. Yes, the temperature depends on the height, whereas height is an independent variable. Right? Height exists here, and depending upon the height, the temperature changes. It means that the height is an independent variable, whereas the temperature is a dependent variable. There may be many factors influencing the temperature, such as humidity, pressure, even air pollution. Right? It's a major issue today. All such factors have a relationship with the temperature, which can be written mathematically as an equation. Defining the regression function. So any equation that is a function of the dependent variables and a set of weights is called as a regression function. Equating with our previous example, we have the independent variable called as the height, and we have the dependent variables which are nothing but the temperature, humidity, air pollution or air conditions, etc., and some set of weights. An equation that is a function of a dependent variables and a set of weights is called as a regression function. Y is a function of x and w, whereas y is a dependent variable in the above example, the temperature, whereas x are the independent variables like humidity and pressure. W is the weights. Weights is the basic weight of a neural network. An example equation is as below. So y is equal to 0.5x1 plus 2.15x2, 0.76x3, whereas 0.5, 2.15, 0.76 are the weights of the equation. So how the weights are determined? The weights are to be learned by studying the relationship between the dependent as well as the independent variables. So gradient in plain terms means slope or a slant of a surface. So gradient descent literally means descending a slope to reach the lowest point. Let's imagine a two-dimensional graph such as parabola. This is a parabola, right? We call this mathematically parabola defined by the equation. So in the above graph, the lowest point on the parabola occurs at x is equals to 1. When x is 1, the lowest point occurs. See, the objective of gradient descent algorithm is to find the value of x such that the y is minimum. As we saw in our earlier modules, optimization is the objective of a neural network. So here I would like to introduce a term called as agile. Agile is a pretty known term in software circles. So what is agile? Derive a solution and iterate the solution. Check out how the solution works for the given problem statement. Then make little changes. Iterate it. Do it in a faster way. Immediately arrive at a solution. Iterate it to check whether the solution works for the problem statements and optimize it until the point where the best solution is obtained. So that is the concept of agile. And your gradient descent is an agile methodology on play. Agile is a pretty well-known term in the software development process. The basic idea behind it is very simple. Build something quick, get it out there, get some feedback, make changes depending on the feedback, and repeat the process. The idea of start with a solution as soon as possible, measure, iterate as frequently as possible is basically a gradient descent. A gradient descent algorithm is an iterative process that takes us to the minimum of function. Yes, that's right. So that's a process of optimization. So the equation is represented in the simple terms. Here is the next expected position. This is the current position. This is a small step or the learning rate. And the direction of the fastest increase. As we saw in our earlier modules, optimization is the objective of a neural network. So here I would like to introduce a term called as agile. Agile is a pretty known term in software circles. So what is agile? Derive a solution and iterate the solution. Check out how the solution works for the given problem statement. Then make little changes. Iterate it. Do it in a faster way. Immediately arrive at a solution. Iterate it to check whether the solution works for the problem statements and optimize it until the point where the best solution is obtained. So that is the concept of agile. And your gradient descent is an agile methodology on play. Agile is a pretty well-known term in the software development process. The basic idea behind it is very simple. Build something quick, get it out there, get some feedback, make changes depending on the feedback, and repeat the process. The idea of start with the solution as soon as possible, measure, iterate as frequently as possible is basically a gradient descent. A gradient descent algorithm is an iterative process that takes us to the minimum of the function. Yes, that's right. So that's a process of optimization. Some more definition of the loss function or the cost function. The cost function or the loss function is the same. A cost function or the loss function evaluates the performance of a machine learning algorithm. The loss function computes the error for a single training example, while the cost function is the average of the loss functions of all the training examples, the summated average. Let's say there are n points in data set, n number of points in data set, and we want to minimize the error. So cost function is a total squared error, is a square of the difference between the errors. So y dash is the expected state, whereas y is the obtained state. The difference between y dash to y and the squared value of the points 1 to n is nothing but your mean squared error function. I mean to say, this cost function is being subjected to MSE, mean squared error function. Let's have an exclusive module only for the error functions, just like the module we had for activation functions. So it's obvious, the goal of any machine learning algorithm is to minimize the cost function, the optimization. Thanks for your time and your patience and your learning. All the best.